some time series analysis. Thanks, Tillman.
Yeah, so I'm going to be just to introduce myself. My name's Tillman. I've been at Sentry for about 3 years, and I manage the data team. And I'm going to be talking about some of our adventures in time series analysis at Sentry. And I do apologize if something doesn't make a lot of sense in the slides. It's hard to read. They were slapped together in a very short period of time, so that's my excuse. So there's two topics I'm going to be talking about. The first is the work we're doing on a new escalating issues algorithm. And the second is around trend detection at Sentry. And also didn't really do too much of a time check, so we'll kind of see how far I can get. So just a quick intro, what an issue is. Good segue actually from the last talk, because it's kind of in the Sentry world, the thing that would precipitate an incident, hopefully. And canonically, it's an issue with your code. It's some problem somewhere that's causing an issue that's making your website stop working, making your game crash, whatever. In the case of errors, it's a just grouping of events that we think are similar to each other. So this is basically, just for context, what the issue feed looks like at Sentry. Each of the items here is kind of like a folder of a bunch of different errors. They've been like hashed into one category, and it's to make 100,000 events roll up into one. One thing you might have noticed is, and this is, by the way, the Sentry product. So it's like not the best look, I guess, but it's a pretty common situation where our enterprise customers, just big companies, they generate a lot of issues, and they, as a result, have a lot of noise in their issue feed. So this is definitely something we're aware of and something we're trying to work on at Sentry. There's a lot of different opportunities to make it better and a lot of different things we're looking into. I'm going to go through them super quickly. Issue grouping, that's kind of the top of the funnel, right? Taking events, and maybe like right now there's some issue with an SDK where a stack trace isn't being parameterized the way we'd like it to, and 100 events that should really be grouped into one issue are getting sent into 20 different issues. So that's something that we can improve on the top of the funnel by making the grouping better. Can also just filter stuff out that we're very confident aren't real issues that people actually don't care about. That's risky because you obviously don't want to have a sort of scenario where you filter something out, but it actually did matter and you just didn't tell them about it. You can also do prioritization. So we can try to put the stuff that we think is the most important and the most relevant at the top of your feed. And the thing I'm going to be talking a little bit about today is our very sort of simple approach and brainstorming process to this idea of archiving stale issues. And it's sort of like taking the first thing, the top of the funnel, and flipping it. So what we're trying to do is just make it really, really easy for issues that you don't care about to go away. So if you have 10,000 issues, and like you're like any other developer and you're kind of lazy and you don't really feel like going in and like hitting ignore and like doing all this stuff to make it go away, you just want it to kind of happen for you. This is for you. That's the persona we're kind of targeting with this. And the idea is it's really simple and eventually automatic for issues to kind of just disappear so you don't have to worry about them anymore. And instead what we do is we actually monitor them and we alert you if something unusual happens, like they start spiking in volume, and that's when you find out about them again. So it's sort of like you can forget about things, but you still have some peace of mind. So just a quick walkthrough of like how that flow kind of looks. It might be hard to read for folks in the back, but I'll just go through it super quickly. The idea is an issue is marked. I mean, it's basically what I just said. An issue is marked as we want to archive it either automatically or manually. Kick off a process where we start generating forecasts for it and keeping track of the issue state. And then if an issue switches to the escalating state, that's when we trigger a workflow. So maybe we will be sending an alert to the user. Maybe they'll be getting like a special badge on it. It'll go to the top of the feed, whatever process they want. One thing that I want to call out that makes this a little bit challenging is there's definitely some competing priorities. One thing that's important is we have to be very quick, right? So if an archived issue just starts blowing up, we can't tell you about it in like 6 hours or 12 hours because likely the incident is already materialized by then. Maybe your customers have complained to you. So we have to be pretty quick, which is challenging because obviously that increases the likelihood that either we introduce false positives or false negatives. And those are obviously both bad. We don't want either. But false negatives are really bad. Because a false negative would be basically, we never told you about the problem and it like broke your website and everyone hates you and like you don't like Sentry anymore. So the chart here, sorry, this I was just copying stuff from a notebook right before this. The chart here is just showing some examples of like what we sort of want this to look like. And we do have this running sort of internally, so that's where I kind of got the screenshot from, which would be like this, you have this escalating badge. So if we look at the chart at the bottom, a couple things I want to call out. The orange line is basically, you can think of as like what we would use as input data for this. We take 7 days of input data, use that to generate a sort of ceiling, which we think logically represents the maximum hourly value for this issue before it's something that you should know about. And then the blue line is an example of an actual escalating issue where we can see that it randomly jumped up and crossed that ceiling. This is actually a funny example too, because it's also sort of a false positive, like there wasn't actually an issue, it was actually a blip, but kind of highlights how challenging it can be to do this right. And also highlights why we want a bias to allow for false positives at the expense and avoid false negatives, kind of bias in that direction. So just to talk about our logic a little bit, it's basically and one thing I know the sort of theme for this event is like optimizing data science or something along those lines. So one thing that we haven't talked about yet as another way of optimizing data science is just to do like really, really simple things and make it so simple you don't actually have to optimize it for it to work. And that's sort of the approach we've gone for here. Essentially, we were like, okay, we're just going to take the average over the last 7 days. And the reason we chose that as opposed to something fancier that's more robust outliers is actually, I'll get to that in a second. And also the variance, and then maybe a small adjustment for the day of the week. And we basically translate that into a multiplier. That is then the threshold at which we are evaluating whether or not an issue is escalating. Oh, sorry. I thought I had one more slide. I think I accidentally deleted the slide. The reason, I just want to call one thing out. The reason we added this multiplier is because one thing that is easy to forget about, like, so my background is in stats. I'm very interested in doing things in a way that makes sense from a stats perspective. And that's kind of a bad instinct in this case, because if we're thinking about the real world application for this, people don't really care if an issue's volume is statistically significant or anything like that. It's useful for us to reason about whether or not we should tell them, but ultimately that's not what like our people care about. So for example, if an issue typically happens 100 times an hour, the standard deviation is 0, like it's just flat at 100 for whatever reason. Maybe it's a very stable job, whatever. And then it spikes to 100, well, spikes to 120 times an hour. No one actually cares, right? It's super statistically significant, p-value 0, but like no one actually cares that that happened because it's just a 20% increase. And so that's why we kind of have these guardrails in place in terms of, okay, it's not going to be less than 5 or greater than 8. But one issue that we noticed really quickly with this simple approach is cron jobs, or any kind of airflow, any kind of job scheduler. It's a pretty typical problem where there'll be a thing that runs at a specific time, maybe once per day. So you'll have 0 errors, 0 events for 23 out of the 24 hours. And then one of those hours and one of those minutes, you have a huge spike, and then it goes back to normal. And so if you look here, the orange line is basically what our sort of simple logic would give us in terms of a threshold. And you can just see based on the blue line that that doesn't work. We're going to just spam you with false positives. So the simple solution that we chose here is, rather than think about the average as the thing we care about, we're thinking about the max as the thing we care about. So we're using 2 ingredients. We're basically using the maximum hourly value over the past 7 days, and we're combining that with the coefficient of variation, which is just the standard deviation divided by the mean. And the sort of the intuition here is that if you have a very bursty issue, it's going to have a very high coefficient of variation, because the mean is going to be very close to the baseline value of 0, and the variance is going to be quite high. And for the issues that we don't want the Bursty issues algorithm to apply to, the coefficient of variation is going to be comparatively lower. And instead, the Bursty issue threshold is just going to be very low and essentially not apply. There's one other point I wanted to make. Any questions so far? Okay, cool. Yeah, go ahead. Yeah, I mean, so like, so there's the obvious option here is to think about it as like a sort of a forecasting problem, right? So we want to forecast all these things, build a confidence interval around the forecast, and see, okay, how far closer are we from that forecast? And that actually works fine. Like, there's nothing wrong with that approach. It's more, I'd say it's more um, constraint, which is we're working within the confines of the Sentry mono repo. And there's a lot of restrictions that imposes on us. And there's, if you look at Sentry, there's like, look at the Sentry like requirements.txt, there's not a lot of like statistical packages in there. And so we have to be a little bit creative in terms of how we solve some of these problems. Having said that, like that's also kind of a problem we're aware of. And I think there's some light on the horizon in terms of like ways to get around that. But honestly, that's like the main reason is we just had a pretty clear restriction in terms of what we could do. Yeah, go ahead. Yeah. You mean in terms of like edge cases? Yeah, I'd say these are like the two main ones. I guess one other challenge, and actually this goes back to the forecasting approach, and one reason why it can actually not be as good is if you think about like, this is a really good example where the forecasting approach can actually be problematic. So let's say we build, maybe we use a simple like exponential smoothing or some relatively simple way of forecasting this pattern. But then, and this is a cron job, it runs at midnight UTC. Like, what if they just change it so that it starts running at 6 a.m. UTC? So any forecast we make that's like reasonable is just going to be like, oh no, everything's like falling apart. But actually, it just offset by a few hours. And so that's another example of a challenge we have to be wary about. Is like we obviously, it's maybe not quite as bad of a customer experience because they at least know why we're telling them it's escalating, but like it's not a desirable outcome. Like it's, they know it's not escalating, we know it's not escalating. So yeah, I kind of forgot the last point, but you guys get the idea. So the final oh, sorry, go ahead. Say that one more time. Yeah. So it's set up it's basically set up as a batch job that runs. So this job will run for every issue once per week. Yeah, so every issue will have its threshold recalculated every 7 days using the past 7 days. So it's oh yes, understood. You're saying that we're potentially missing yeah. So the short answer is yes, we're explicitly not addressing that. There is cooling in Sentry that you can combine with. So the idea behind this is it's more of like the stuff you really just want to get rid of, and you want to know if something crazy happens with it, but otherwise you want to get rid of it. This is the tool for that. For something like that, you can basically just set a rule where it's like, hey, if it goes above this limit, then I need to know about it. So that we're not getting rid of that functionality. Yeah. Yeah. No, so an issue, and I'm defining an issue very narrowly here, actually. An issue is a collection of errors that your code generates. So a lot of the time that's bad. Usually it's bad, but there's also like, it could be like an info level thing where it's like just telling you, like maybe there was an API connection that failed, and then it retried it and it succeeded. So there's a lot of, errors that show up as issues that like, it's just stuff you genuinely don't care about, but maybe, and that's actually another good example, because let's say all of a sudden these connection errors spike. Maybe that's a point where you actually care about it. Cool. All right, let's keep moving. And so, yeah, again, we're basically just taking these two limits and taking the max of them. And yeah, we can see that in this cron job example, it works pretty well. Like basically, again, the limit that's based on the average applies to most time series, and then this bursty limit applies to the sort of cron job example. Okay, cool. So it's been 15 minutes, so I think I could spend at least a little bit of time talking about the next thing, which is performance issues. So this is a relatively new feature that we've added at Sentry. The sort of concept is we basically tell you when your code is slow, or when it's slowing down, or when you've done like dumb things. So examples of that would be like n+1 DB queries, or you have an uncompressed asset in your page that's like making a page load really slowly. And these are really great because they're very targeted and they're very prescriptive. Like we can tell you like, hey, like your page is slow, here's why, you should go fix it. But the limitation with what we have right now is that we're also kind of constrained in terms of what we can surface. So if you have an API endpoint and it just gets slower, we're not really going to tell you about it if we don't know exactly why. It's just going to get slower, and then maybe like one day you notice that it's slower, and that's not great. So the idea for this, and by the way, this is the last thing, was something that's like pretty soon going to be entering EA, and this is something that's like kind of at the early stages. I'm just rambling about random stuff I'm working on, so this is like pretty far away. But the idea is that we're analyzing all of the metrics associated with all of your transactions, and we're identifying trends. And we're then using the analysis we've done on those trends to combine that with our data on your spans. And if you have profiling, your profiling data, to actually do root cause analysis. And the sort of upshot of all of this is that any generic performance regression across any one of your metrics, we can now tell you about it, and we can at least try to give you somewhat of a prescriptive idea of like what might be going wrong. So I'm just going to go through a couple of charts and examples of like some of the nuance and difficulties with this, and why you have to get a little bit fancier than the super basic approach we were just talking about. So one obvious solution is like, okay, we take all these different time series, and we just see, pick an arbitrary midpoint and see, are they changing? And this is a good example of why that doesn't work. You want to know about these things relatively soon after they occur. And if we're just doing something like this, like comparing the median before and after, you're going to have a big lag in how long it takes for you to find out about it. Like here, we're saying it's 2% slower, but we can see it's clearly spiked. So kind of an anomaly detection approach can be problematic because generally speaking, we don't really care if something's spiking for a relatively short period of time, because there's probably also errors associated with that anyway. What we're really looking for is like someone committed some code and it just like they introduced something that slowed the system down in a very structural way. And so it kind of has to have some staying power. So here's an example of like, this is a P50 duration for an endpoint that kind of just changes a lot. And we wouldn't want to be flagging a bunch of different performance regressions for this because it's really just noise. So there's sort of the approach we're kind of headed down right now is this combination of breakpoint detection. So we're using a pretty simple breakpoint detection algorithm from a very long time ago. It's the QSUM algorithm with also a very simple t-test. And the basic idea is we use breakpoint detection to identify the most recent point in time at which this metric is regressed. And then we use a t-test to basically confirm that that regression is significant or not. And where I think this gets interesting and what we're working on right now is we can actually combine that with span analysis. And that's one of the reasons actually, so there's a lot of different, again, similar to the last thing I was talking about, there's a lot of different ways to do this. And one of the reasons why, for example, a forecasting approach, but one of the reasons why this breakpoint detection is really effective is because it actually lets us identify our best guess for when the actual change happened, like when the regression happened, which does two things that are really useful. One, we can use that to pinpoint the specific commit or release that introduced the performance regression. And two, we have a nice before and after time period that we can use for span analysis. So spans, it's kind of in the right here of this of, wow, it's pretty blurry. Maybe I have bad eyes. I don't know. But the spans are on the right, and that's just all the different operations that went into your transaction. Um, and the idea is, okay, we can do some statistical analysis on all the spans before this regression, before the breakpoint, do some analysis on all the spans after the breakpoint, and basically see what's the delta, like what changed, what got worse, what was added. And that's this really nice sort of starting point for someone to actually do root cause analysis and actually pinpoint and hopefully resolve the problem. Yeah, so just kind of putting it all together. Into some discrete steps. We're kind of on step one right now in terms of development perspective. We're just starting on the span analysis this quarter. But first, we try to have a very rigorous way of identifying regressions. Two, we want to have some really cool analysis that helps us identify the root cause and all the details that go into those regressions. And three, we want to put it all together and surface to our users. And I think, yeah, that is it. I was told to add a slide on my GitHub, so I don't have an Instagram. Okay. Yeah. Great. Well, thanks. Any questions on kind of the second half or the first half, I guess? No, a span. It's basically a word for the operations that are happening in the background. So if you like, it's sort of like some Sentry specific terminology. So like you have a transaction, which represents like conceptually a transaction represents like a discrete action on in your application. So maybe it's an API endpoint. And then within that API endpoint, there's a bunch of other operations that happen between like it being hit and it sending a response. And the span tree represents like all of the sort of things that happen that went into that response. And so the idea is like maybe to give a specific example, let's say an API endpoint goes from taking 100 milliseconds to 500 milliseconds. And one of the items in that span is a DB query. And we can see, oh, hey, this DB query that used to take 50 milliseconds is now taking 450 milliseconds. And then we can see, oh, like someone, I don't know, they did something really stupid with the query and made it way slower. And then, it's easy to sort of figure out why the transaction got slower. Yeah. Yeah, it's a great question. So one thing that's actually nice is we're very constrained just by virtue of Sentry's infrastructure and how it's set up. So there's sort of some natural guardrails in place already. But to your point, like I think the way you described it is exactly how I kind of think about it too, which is, at the end of the day, we have a lot of customers, and those customers represent a lot of different programming languages, a lot of different use cases, a lot of different things they're trying to do. And as a result, like, and this is honestly a kind of a problem for the stuff I'm talking about here, but it's a huge problem for grouping, which is like how we group the individual errors into the issues. And it's because it's very subjective what a group actually represents. Like there could be two different organizations that have in their own minds like very different conceptions of what should be grouped together and what shouldn't be grouped together. Um, so really like the idea, I guess to actually answer your question, um, it's, in my opinion, an exercise of just finding the highest leverage stuff we can do that is the lowest effort. And that's a good example of that is definitely this escalating issues thing where it's like, yeah, we could, do all these other things, but we can also just get rid of the stuff that's crap that you don't care about. And that's a really easy way of making the issue stream a lot cleaner. Yeah. Yeah, that's actually like basically like I'm sort of making this logical leap that if an issue is happening regularly, it doesn't matter. And you're saying like, how does like where does that leap come from? Yeah, yeah, no, it's a really good question. So there's two ways to think about it. And like I think the intuition, the intuition is that if an issue is happening and it's not going down to zero, which means you're not fixing it and you're not doing anything about it, then it probably doesn't matter. That's sort of the basic intuition, right? Like, and you know, like Sentry's. Let me just go back to this guy. Like Sentry's a good example of that, right? There's a lot of just stuff that happens that people just don't really care about, and so we can sort of say that, okay, if a thing has happened, it's been happening consistently for 3 days. Yeah, maybe they just haven't fixed it yet. If it's happening consistently for 7 days, like yeah, it's been a while. It's happening consistency for 30 days, consistently for 30 days. It's like, okay, like this is kind of sketchy. And then there's stuff that's happening consistently for like 180 days. It's like, okay, this definitely doesn't matter. So it's sort of like clearly there's like this decay function, right? Where it's like the longer an issue persists, and nothing's changing in its sort of steady state behavior, the more likely it is that no one cares about it. And so we can put in some sort of some defaults in terms of how this automation works. And you can do smarter things, right? You can do things like only archive the issues that no one's looking at or no one has assigned, or there's a lot of things you can do to make it smarter. But that's kind of the basic intuition. Yeah, I mean, so the ingredients that I would think about are that, yes. You can sort of extrapolate based on this sort of statistical pattern that you were just talking about. But there's also there's like much more discrete signals out there. So for example, we can, we instrument all of our page analytics and we instrument all the things people are doing with issues. So another way of thinking about it is like, and actually I might be answering a different question. So please let me know if I'm like going a totally different direction. But another way of thinking about it is like, we're pretty confident an issue is like stale and no one cares about it if no one's actually like if there's no analytics events associated with it because no one's going to it and no one's assigning anyone to resolve it. And likewise, maybe an issue that's been around for 14 days, but we can see, people are actually engaged with it and actually like, writing comments on the issue and like assigning stuff to other people. That's probably something that's just a long-standing problem that like is still not resolved. Does that answer your question, or were you asking something different? Yeah. Yeah, that's a very concise way of putting it. Yeah. I mean, you can think of it that way. It's sort of like we there I guess there's a lot of different ways to kind of conceptualize it, but at the end of the day, it's like we're trying to take all of our observable data, right? So we can see how stale are all the issues, how many people are engaging with all the issues, how long have all those issues persisted, how active are people on those issues. We have all this like rich contextual data, and based on that, we can see like, okay, what are the patterns? Like, so if an issue is stale for this many days and this many people are engaging with it, uh, there's a 99% chance it'll never ever get resolved. So we can like, very easily build these relationships between the data and a pretty reasonable conception of like what are people actually doing and do people actually care about these things. And then it's just a matter of like assigning a threshold that seems reasonable. Nothing's ever going to be perfect, but really the goal here at the end of the day is just to make Sentry's like signal to noise ratio as high as possible. So we're giving people, so you get an alert and there's the best possible chance it's actually relevant to you, or you go to the issue feed and there's the best possible chance the thing that's the thing that's at the top is something you actually care about. Damn. All right. Guess I'm done.
All right. Well, thanks. Thanks. Thanks.